Okay, I have chosen to model the equation 3 times the quantity x minus 5 squared equals 27. So the way I'm going to go about this is I think about if I were to plug something in for x, the order of operations I would follow would be first to evaluate anything inside of the parentheses. So I would take the x value and subtract the 5. The second operation I would complete is the exponent. I would raise that quantity of x minus 5 to the second power. And then I would use the multiplication that I see by 3. So when solving, I am actually going to do these same operations, but in the reverse order to solve, and basically eliminate everything else that's happening around this x value. So that means I have to start by undoing my multiplication. So the way I undo the multiplication here is I divide both sides of my equation by 3. So when multiplying the left-hand side, or dividing the left-hand side by 3, then that undoes the multiplication and leaves me with just x minus 5 squared. When applying that division to the right-hand side of my equation, I would have 27 divided by 3, which is 9. So that undoes this step right here of multiplication. Now to undo an exponent, I use a root. The opposite of squaring something is to take the square root. So over here, I make sure that I do that operation to both sides and taking the square root. When I do that, now depending on the purposes that you're solving for, or maybe even the teacher and their preferences, I know that these will undo one another and just leave me with an x minus 5. However, when I take the square root of 9, like I say, if we know our purpose here, taking a square root typically yields two results, a positive 3 and a negative 3. So I would have to set up my first equation, x minus 5 equals 3. I'd have to set up a second equation where x minus 5 could also be equal to negative 3, representing both of those answers. And again, depending on the purpose of solving this, we may not need both solutions, but here we're going to find all possible. So that, taking a root, undid the exponent. And now, since I no longer have parentheses, I've basically uncovered what was inside the parentheses and unlocked that. I can just undo my remaining operations here, which is to add 5 to both sides. I can do the same thing with my second equation. And now I found two possible solutions where x is equal to 8, or a second possible solution over here, x is equal to 2. And in a quadratic equation, I would talk about how this makes sense to find two possible solutions, because in a quadratic, we're dealing with parabolas and potentially two places where it crosses the x-axis. So that is my solution right there.